Another form of quadratics that we want to look at is vertex form. Vertex form is f of x equals a, and then in parentheses x minus h, close parentheses squared, plus k. hk is your vertex. So on number 1, we've got f of x equals 2. 2 is the a, and then the vertex is the hk. The h is positive 2. Notice that there's a minus in the formula, and then the k is positive 4. Vertex on number 2 is negative 3, negative 5. Again, minus in the formula. And then the a is negative 4. On number 3, a is negative 1. You see a negative sign, you don't see a number with it, so that's a negative 1. And then the vertex is 1, negative 2. Remember, the minus is already there from the formula. So for this one, our a is 2. That means it will open up because it's positive. If it opens up, then it will have a minimum point. Axis symmetry always goes through the vertex, so let's see if we can spot the vertex here. Vertex is 3, negative 4. That's the h and k from the formula. Axis symmetry always goes through the vertex, so it'll be x equals 3. The y-intercept, we have to do a little bit more work on this one. We've got to plug in 0 and find the y value, the f of x value at 0. So everywhere there's an x, we can put 0 and see what comes out of it. Again, 0. Zero minus 3 is negative 3. Negative 3 in parentheses squared is negative 3 times negative 3. That's positive 9. And so we'll have 2 times 9, 18 minus 4. 18 minus 4 gives us 14 for the y-intercept. Alright, let's go ahead and graph what we have so far. X equals 3. Is your axis symmetry. We've got a vertex at 3, negative 4. And we know we're opening up. 0, 14 is our y-intercept. Not very helpful here because we can't even plot it unless we extended our graph out. Let's find a point to the right of this. So let's put in 4 and see what happens. Everywhere there's an x, I put a 4. Use the order of operations to simplify this. 4 minus 3 is 1. Next we'll do exponents. 1 squared. 1 times 1 is 1. We'll multiply. 2 times 1 is 2. 2 minus 4 is negative 2. So we have an additional point at 4, negative 2. We'll plot that point, 4, negative 2. It's 1 unit away from the axis symmetry to the right of that, and it has a y value of negative 2. So if we reflect that, we will have a point at 2, negative 2 as well. We'll go ahead and connect those and draw our arrows. Vertex form is especially nice at finding the vertex. A little bit harder to find the y-intercept than standard form is. It emphasizes the vertex. You can pause the video and try this one. Alright, you should see that a is negative 1, so it opens down anytime a is negative. If it's opening down, then it will have a maximum point. If you can spot the vertex, vertex is negative 5, 2. Notice that the in front of the h in the formula is a minus. Axis symmetry always goes through the vertex, so we have x equals negative 5 as our axis of symmetry. A little bit harder to find the y-intercept here, so we're going to replace x with 0 and substitute in and simplify the right side. 0 plus 5 gives us 5. 5 squared is going to be 25. And then the opposite, the negative is in front, negative 25. Negative 25 plus 2 is negative 23. Y-intercept 0, negative 23. All right, we need a couple of additional points. Let's go ahead and plot what we have so far, I guess. Axis symmetry, x equals negative 5. Vertical line. We have a point at negative 5, positive 2. That's your vertex, and it's opening down. So let's put in negative 4 and see what happens. So we're plugging in negative 4. We chose that again because it was close to the axis symmetry, close to the vertex. We don't want to go real far away from the vertex because our values get really big or really small quickly. Negative 4 plus 5 is 1. 1 squared is 1. The opposite of 1, negative 1. Plus 2 is 1. So we have an additional point at negative 4, 1. So we'll take that value and we'll plot that point. We can reflect that point. Across that axis symmetry, it's 1 unit away from it, and it has a y value of 1. And then we'll connect those with a smooth curve. Another form we may see is called factored form. P and Q are called the zeros, or you can call them the roots. And anytime we want to find the axis symmetry, we can average the two roots or zeros together. So if you think through solving quadratics by factoring, which we did in a previous unit, we can set each factor equal to 0 and solve. So if you're on the x-intercept, x-axis I should say, the y value has to be 0. If you have a product equal to 0, at least one of those factors has to equal 0. The negative 3 factor won't give you any solutions, but the x minus 1 will give you a solution. And also the x plus 2 will give you a solution. Add 1 to each side, you get positive 1. So that's an x value. The y value is 0 anytime you're on the x-axis. Subtract 2. Negative 2 is the other 0. Axis symmetry, average your two, the p and the q. So x equals 1 plus negative 2 over 2. So x equals negative 1/2 here. Number 2, our x-intercepts are, if you set this equal to 0 and solve, subtract 3, you get negative 3. The other root that you would see would also be negative 3, 0. So this is one of those quadratics that hits the x-axis one time. Your axis symmetry is the average of the p and the q. So negative 3 plus negative 3 is negative 6 divided by 2, negative 3. So axis symmetry is going through that vertex of negative 3, 0. If we set each of these equal to 0 on number 3, we'll have x minus 7 equals 0. You can add 7 and you'll see the 7. So we have an x-intercept at 7, 0. If you let x plus 1 equal 0, solve that, you get negative 1 as the other root, or 0, or x-intercept. If you average those together, 7 plus negative 1, you get 6, divided by 2, you get 3. So this time we see an axis symmetry at x equals 3. So these factored form quadratic equations emphasize the roots, or you can say the zeros, the x-intercepts. All right, so on this one, a is negative 2. Since a is negative, it's going to open down. Axis symmetry is the average of the 3 and the 2. 3 plus 2 is 5, 5 halves, or 2.5. Or 2.5 if you prefer. Vertex, not so easy to find the vertex here. We know it's got the same x value as the axis symmetry, but we're going to have to do some calculations to figure out this vertex. Alright, so plugging in 2.5. Using our order of operations, we'll do what's in parentheses first. We get negative 1/2. And over here we'll get positive 1/2. Multiply all of those together. Negative 2 times negative 1/2 is positive 1 times 1/2 is 1/2. So we have a vertex at 2.5, 1/2. X-intercepts are easy to spot here. If you need to, you can write it out. X minus 3 equals 0 and solve that. The other one will be x minus 2 equals 0. Solve that. So we'll add 3 and get positive 3. So we have an x-intercept at 3, 0. Add 2 to each side and you get x equal to 2. So we have another x-intercept at 2, 0. To find the y-intercept, we'll replace x with 0 and simplify the right side. Plugging in 0, 0 minus 3 is negative 3. 0 minus 2 is negative 2. And then we'll multiply from left to right. So f of 0 equals negative 2 times negative 3 is 6. 6 times negative 2 gives us negative 12. Y-intercept 0, negative 12. We can plot all of our information that we have. We've got a point at 3, 0, point at 2, 0. Yeah, that's right. Vertex halfway between there, 2.5, and then the y value is 1/2. So let's put in, let's say 4 and see what happens for our additional point. 4 minus 3 gives us 1. 4 minus 2 gives us 2. Multiply those 3 together. And so f of 4 equals negative 2 times 1 is negative 2 times 2, negative 4. So 4, negative 4. We can reflect that across the axis symmetry. It's 1.5 units away from that. So we can put a point at 1, negative 4 as well. So the additional point we found, 4, negative 4. You can pause the video and try this problem. All right, A is positive, or there's no number in front, so it's a 1. So A is positive, it opens up. Excuse me. X is symmetry, average of the P and the Q. So the P here is -1. It may, I guess you can write it down, x plus 1 equals 0 and solve, or x minus 4 equals 0 and solve. That gets you to the zeros, the x-intercepts. -1, 0 is one of those. Add 4, and you'll see 4, 0 is the other one. X is symmetry. X equals the average of those two. So the average of -1 and 4. That, add them together, you get 3 halves, or 1 1/2. Vertex, you'd have to plug the 1 1/2 in. So plugging in the 1 1/2, you'll add 1 1/2 plus 1, 2 1/2. 1 1/2 minus 4, -2 1/2. And then you can multiply those together. And you should be getting -6 1/4, I believe, when you multiply those together. All right, so we have our vertex now. Find the y-intercept, replace x with 0 and solve for y. 0 plus 1 is 1, 0 minus 4 is -4, 1 times -4 is -4, and so we have a y-intercept at 0, -4. An additional point, we can put in something to the right of that axis symmetry, like 2. So everywhere there's an x, we'll put 2, and we'll see what comes out. So we have 2 plus 1, 2 minus 4. 2 plus 1 is 3, 2 minus 4, -2. Multiply them together, -6. So f of 2 is -6. And now we'll plot all those points. All right, so I plotted the vertex 1 1/2, -6 1/4. The axis symmetry, x equals 1 1/2. X-intercepts, -1 0. And then also 4 0. And we did an additional point at 2, -6. If we want to reflect that across the axis symmetry, we can. And now we'll connect those for our parabola. So hopefully you've enjoyed this video on vertex and factored form of parabolas.